Hey guys, welcome to day 45 of 100 Days of Code. Now today we're going to be getting back to coding with Python, and we're going to be learning how to scrape the web for data using a module called Beautiful Soup. Now we've been working with APIs for quite a while now, and we know that we can use a website's API to access their data or to interact with the website using code. But some websites don't have an API, or their API doesn't let us do all the things that we want to do. So this is where we start thinking about using web scraping, where we look through the underlying HTML code of a website to get hold of the information that we want. So the aim of today is to learn how to make soup, but not this kind of soup. We're going to be making Beautiful Soup. What exactly is Beautiful Soup? Well, it's a module that helps developers like us make sense of websites. We could think of a lot of websites as a bit of a spaghetti soup. Even something seemingly as simple as the Google front page. When you right-click on it and view page source, you can see that it's horrendously complicated. And if you wanted to make sense of this web page and pull out the relevant parts of the data, then you'll need an HTML parser like Beautiful Soup so that you can find and pull out the HTML elements that you're interested in from this soup of jumbled HTML code. And once we've mastered this skill, then we'll be able to take any website, for example, Empire's 100 Greatest Movies of All Time. This is a huge list of 100 movies that apparently everyone should have watched at some point in their life. And we can pull out the relevant parts to us, namely the title and the ranking of each movie. And we're going to use it to compile a list of movies that we have to watch so that we can look at the list, cross out the ones that we've already seen, and then pick at random one from the list so that we can watch all of the 100 movies of all time. That's the goal. And once you're ready, head over to the next lesson and we're going to get started using Beautiful Soup. In this lesson, we're going to get started using a library called Beautiful Soup to parse an HTML file. Parsing the HTML file is the first step to extracting the data contained in a website. To get started, the first thing I want you to do is to head over to the course resources and download the starting project for today. It's called BS4 Start, and once you've extracted it and open it in PyCharm, then I want you to take a look inside. First, we've got an empty main.py file, which we're going to write in order to use Beautiful Soup and extract the data that we want. And the data is going to come from this website.html. Now, a really nice thing about PyCharm is when you have an HTML file, you can always just click on your favorite browser icon here, and it will open up the website as it is. And you can see that this is a simplified version of our HTML CV page that we built on day 41. Now, if you've skipped over day 41 to 44 because you already know HTML and CSS, then have a quick read through the HTML. It's a very simple document with a bunch of different HTML tags, attributes like class and ID, and also a list. I've kept this as simple as possible just so that it's easy for us to work through it when we're trying to get hold of things using Beautiful Soup. In the course resources, I've also got a link to the Beautiful Soup documentation. So this is where you can find out everything that you can do with Beautiful Soup. But I want to walk you through some of the most commonly used components. Beautiful Soup, as they say, is a Python library for pulling data out of HTML and XML files. So HTML and XML are both structural languages, and they're responsible for structuring data, like the data in a website, using these tags. And the great thing about Beautiful Soup is it's super easy to use, and it can save you hours or days of work to get hold of the data that you want from a particular website. And you can see the documentation's also been translated by kind users into some other languages as well. So if you find it easier, then these languages might help you as well. Now, the first thing I have to do here in my main.py is to actually get a hold of this particular file. Now, you might remember from previous lessons how we open a file in Python. So have a quick think and see if you can figure out how to get a hold of the content in this HTML file as a string or as a piece of text. Pause the video and see if you can complete this challenge. Just as a hint, you might need the keyword with and the keyword open. All right, so the way we do this is we say with open, and then we provide the name of the file, which is website.html. And we can open this as an alias name, which we'll call file. And now we have access to this file, and we can say file.read. Now, once we read this file, we can save this to a variable, which we'll call contents. And once we've gotten hold of these contents, then we can start using Beautiful Soup. So as always, we always start with the import. So the name of the library that we're going to install is called BS4, and this is Beautiful Soup version 4, which is currently the latest version of Beautiful Soup. And from this particular package, we want to import the class, which is called Beautiful Soup. Now, if you downloaded this project from the course resources, you should see that there's no errors underlining this line because BS4 has already been installed. If you see some squiggly underlines, just click on the red light bulb and install the required module, which is called Beautiful Soup 4. Now, once we've got hold of our Beautiful Soup class, then we're ready to make soup. In order to make soup, we use our Beautiful Soup class and we create a new object from that class and we pass in a string. So this is the markup, and that's the same M that you find in HTML and XML. It's the hypertext markup language and the extensible markup language. So the markup refers to basically all of this. We've already gotten hold of it through this contents, so let's go ahead and pass that in. So now that we've specified what it is we want to use to create our soup, the next thing we have to provide is the parser. This is going to help the Beautiful Soup module understand what language this particular content is structured in. As they mentioned, it can parse HTML and XML, so we have to tell it what particular type of document we've got. And the easiest way is just to use the Python HTML parser. So after we've passed in the text that we want to turn into soup, we're going to add the parser as HTML.parser. And this is going to help Beautiful Soup understand these contents. Now, depending on the website that you're working with, occasionally you might need to use the LXML's parser. And to do that, all you have to do is say import LXML and then install this particular package. And here in a string, instead of using HTML parser, you can use LXML. And this is basically just a different way of parsing or understanding the content that you're passing to Beautiful Soup. And I found that with certain websites, the HTML.parser might not work and you might get an error that tells you something about your parser not working. So then you might consider using LXML instead. So this one line of code basically completes our parsing. And this soup is now an object that allows us to tap into various parts of the website, but using Python code. For example, if I wanted this title tag out of this whole website, all I have to do is say soup.title. And now if I print this soup.title, you can see that we'll get the title tag being printed out in its entirety. Once Beautiful Soup has made sense of this website by parsing the HTML, we can now tap into that object, which is the HTML code, as if it were a Python object. So we can tap into the title, but we can dig even deeper instead of just tapping into the title, we can also get hold of other things like the title.name. And this is going to give us the name of that particular title tag. So remember, this gave us the title tag, so all of this, and this next stage, drilling even deeper into the name of this tag, you'll see that it gives us title. So the name of this title tag is called title, and we can also get hold of the string which is contained in the title tag by simply using .title.string. And you can see this is the actual string that's inside that title tag. If we think about it, this entire soup object now represents our HTML code. So I can also actually just print out the entire soup object. And you can see that this is basically just our HTML. And if you want to, there's even a method called prettify, which will indent your soup HTML code. So now compare this, where everything's all on one line, with this prettified version, where everything's all indented properly and easier to read. In addition to getting the title tag, we can also get hold of, for example, the A tag. So this is going to give us the first anchor tag that it finds in our website, which happens to be this one right here. And we can swap that with maybe the first li or the first paragraph. Essentially, what we're doing with Beautiful Soup is we're just drilling down into this HTML file, finding the HTML tags that we're interested in, and then getting hold of the either name of the tag or the actual text of the tag. But what if we wanted all of the paragraphs or all of the anchor tags in our website? How would we do that? In the next lesson, we're going to dive deeper into searching through websites for all of the components that we're looking for. For example, all of the p tags or all of the anchor tags. And we're going to see how we can refine our search and specify exactly what it is that we want. So for all of that and more, I'll see you on the next lesson. Now, there's two things you'll notice here. One is we're only getting hold of the first, for example, p tag or a tag, but we're not getting hold of any of the other ones. So what if we want to get all of the anchor tags or all of the paragraphs in our website? Well, then we can use a function that comes with Beautiful Soup called find all. This is probably one of the most commonly used methods when it comes to Beautiful Soup. And here we can search by a bunch of things. We could search by name. So we can say find all of the tags where the tag name is equal to A. So this is going to give us all of the anchor tags. And if I print that, you can see that it gives us a list and it gives us all three of the links that exists in our website. And if I change this to P, for example, then it'll find all of the paragraphs, and we can change this to basically any of the tag names in our website. Now, what if we wanted to drill a little bit deeper? We've got a list of all the anchor tags, but what if I only wanted the text in that anchor tag? So I just wanted this part. Well, how would I get hold of all of them? Well, firstly, we would probably need a for loop. So we could say for tag in all anchor tags, and we can loop through all of those anchor tags and use a method called tag.getText. And now if I go ahead and print this, you can see that it's basically going to print out all three of the text that is in all three of the anchor tags that it found. Now, what if I didn't want to get the text, but instead I wanted to get hold of the actual href, so the link, right? So let's print our all anchor tags again. And you can see that there is an attribute called href, which stores the actual link that the tag goes to. So very often you'll want to isolate that link. So how would you do that? Well, you can tap into each of the tags and you can use another method called get. And here you can get the value of any of the attributes. So if I pass an href here and I print this, then it's going to give me all of the links and it's not going to give me anything else. It's basically just stripped out the link, which is what I'm interested in. Similarly, when we use find all, we can also find things by their attribute. So at the moment we're searching by the tag name, but we can also get hold of things by the attribute name. For example, if I wanted to get hold of this item, I can of course search for an H1, but what if I had lots of H1s? Well, then I could isolate it by this ID. So I could say soup.findAll, which will give me a list of all of the items that match the search query. Or I can use the find method to only find the first item that matches the query. In my case, there's only one thing I'm looking for, and this particular tag has a name of H1, but it's also got a ID of name. As you can see, this ID is equal to name and it's also an H1 tag. So this will give us that particular element. So if I print out this heading and let's comment out everything else, then now you can see I've just isolated that one H1. And this also means that if I just add another H1 here, and I run this code again, that is not going to show up because I've said it has to have a name of H1 and an ID that matches this particular value. Now, as you can imagine, you can also do the same thing with the class attribute. So we can say soup.find, because again, I'm only looking for one, and the thing that I'm looking for has a name which is a H3, but it's also got a class that's equal to heading. So I'm just going to copy that and paste that in here. Now, one of the things you'll get here is an error because this class keyword is a reserved keyword in Python. And what that means is that it's a special word which can only be used for creating classes. Now, in this case, we're definitely not creating a class or an object here. Instead, we're trying to tap into an attribute. So in order to not clash with the class keyword, this attribute is actually called class underscore. Now it's going to look for all of the H3s where the class attribute is equal to heading. Let's go ahead and print this section heading, and you should see now we'll get that H3 with the class of heading show up. And again, if we wanted to get hold of the text that's contained in that H3, then we simply use the getText method. Or if we want to know the name of that particular tag, then we can say .name. And if we want to get hold of the value of an attribute, for example, get the class value, then we can do something like this. Now, while that's a pretty good way of selecting elements from the entire website, there's certain cases where it might not work. For example, at the moment here, we've got our 3 anchor tags. If we wanted to get hold of a specific anchor tag, let's say we wanted this anchor tag, then what do? Well, then we could just simply find all of the anchor tags and then find the first one. But as you can imagine, this is a incredibly simple website. Most websites will have thousands, if not tens of thousands of links. In that situation, it's really hard to know which particular link you want from the list of all of the anchor tags. So we want to have a way where we can drill down into a particular element. What's unique about this particular anchor tag? Well, it sits inside a strong tag, and it sits inside an emphasis tag, and it sits inside a paragraph tag, which itself is in the body. We can narrow it down using these steps. In our current website, nowhere else is there an anchor tag that sits inside a paragraph tag. And you'll remember from our previous lessons on CSS that you can use CSS selectors in order to narrow down on a particular element in order to specify its style. And if we were to write CSS code, then it would look something like this. So we would select first the paragraph, and then we would select the anchor tag, and then we can specify what the style should be. Now, when we're using Beautiful Soup, we can also use these CSS selectors. I can get hold of that company URL by simply saying soup, and instead of using find or find all, I'm going to use select one. There's select and there's select one. Select one will give us the first matching item, and select will give us all of the matching items in a list. Now we get to specify the selector as a string. And again, I'm going to use the same selector that I showed you before. So we're looking for a tag which sits inside a p tag. And this string is the CSS selector. So you can write anything in here, really. This means that we'll be able to get that anchor tag. And then once I've gotten hold of the company URL and print it out, you can see it's that exact anchor tag that we wanted. We don't have to just stick to the HTML selectors. You can also use the class or the ID in your CSS selector. So remember, to select on an ID, we use the £. So let's say we want to get hold of this H1, which has an ID of name. We can say £name, and now this is going to be equal to my name. And if I now run it, you can see that last one, the element that was picked out is the H1 with the ID of name. And finally, you can use the CSS selector to select an element by class. So for example, here we've got heading, and here we've got heading as well. So if we want to select all of the elements that have a class of heading, then we could say soup.select. So this will give us a list, and then the selector is the first item that goes into the method. So similar to this, we can have this keyword argument there, or we can delete it. And this selector will be using the dot heading in order to select the element that has a class of heading. And this is now going to be a list if we print it out right here. So you can use everything that you've learned about CSS selectors to select a particular item out of an HTML file. And this is usually really useful because a lot of these elements will be nested inside divs, and the div will have an ID, and then all you have to do is to narrow down on the div and then narrow down on the element you want. So you can basically drill through using CSS selectors to get to any item you want on the page. Now that we've looked at how to find various items from HTML using Beautiful Soup, in the next lesson, I've got a quiz for you to have a go and have some practice at selecting and finding elements from an HTML file using Beautiful Soup. So for all of that and more, head over to the next lesson. In the last lesson, we got started using Beautiful Soup, and we saw how we could use it to pass through the HTML of a website and pull out the pieces that we're interested in. Now, it's no fun scraping a website that you've already got access to locally. It's much better if we can get hold of something that's currently live on the internet. So I'm going to go ahead and comment out all of this code. and I'm going to be using Beautiful Soup to get hold of a live website and grab data from it. And the website that we're going to be using is the Y Combinator's Hacker News website. This is where anybody can post a link to a news piece that they've discovered that's tech related, or you could show off things that you've built. For example, I've just been looking at this guy's website that he built called My Desk Tour, where you can post a picture of your desk setup and you can see all of the tools and gear that they've got. So we're going to be scraping the main Hacker News website, which is under this particular URL. And this is usually where I go to find the latest tech news. We're going to copy this URL and we're going to go back to our main.py. And in order to download the data from that website, we're going to be using our handy friend, which is requests. Now, requests allows us to get hold of the data from a particular URL, which in this case is news.ycombinator.com. And once we've made that request, then we can save the data that we get back in a response variable. And once we've got the response, we can actually print out the text of the response. And this is basically equivalent to what we did when we opened up our HTML file and we read the file contents, the text of the file. So now if I go ahead and run this, then you can see that it's going to print out loads of stuff, but this is basically the code that represents this particular page. So in fact, if you right click and click View Page Source, you'll see that this is exactly the same HTML code that we're getting back over here. So we don't actually want all of this jumbled mess. What we're more interested in is the specific titles and the links for each of these pieces. It shows by default 30 of the top articles, and this is ranked by an algorithm. So it's most recent and also getting a lot of traction, so a lot of upvotes. But it doesn't represent the most upvoted item. So you can see here, in fact, the most upvoted, at least today anyways, is Mozilla laying off 250 employees. So what if I want to get hold of the article title and the link of the post from this page that has the highest points? I don't want to have to manually check all of this. I want to do it with code. So let's go ahead and scrape it. Now, if I right click on each of these titles and I click on inspect, then it takes me to the precise line of code in the HTML that's responsible for rendering this component. This is actually a anchor tag. So that's the A tag. And the text in the anchor tag is the title of the article. And then the href is the link that will take me to the actual story. So if I click on this, you can see it takes me to the actual news piece about Joan Feynman. So what about this point? Well, let's go ahead and right click on it and click inspect. You can see this is in a span and it has a class of score, while this title is in a href and it has a class of storylink. So with those two pieces of information, we can use Beautiful Soup to scrape all of the titles, all of the links, and all of their points. And we can compare all of those points and figure out which one has the highest point on this page. So let's go ahead and do that. So I'm going to save the YC web page as the response.txt. And then I'm going to use Beautiful Soup to parse that web page. So Beautiful Soup, and then I'm going to pass in the actual HTML document that we want to parse. So this is the YC web page. And then we provide the method to which we're going to parse it. So html.parser with an ER at the end. And this is our soup. Once we've created our soup, the next step is actually to dig in the soup and find the parts that we want. So for example, if I want to get hold of the title of all of that, then I can just say print soup.title. And now you'll see it gives me the title, which is Hacker News. And that's the same as what you see here in the tab bar. Now, what if I didn't want the title? What if I actually wanted to get hold of this text here, the title of each of these articles? See if you can figure out how to get hold of this text and print it out in your code. Remember, it has a class that's StoryLink and it's an anchor tag. Pause the video and see if you can get this title. So yours might be different from what I've got on screen, of course. It depends on what's showing up on Hacker News on the day you're doing this. But get the title of the first article printed out using Beautiful Soup. All right, what we want to do is we want to use find. So we're going to find the first instance from this web page where the actual name of the tag is equal to A, so that's an anchor tag. And then the class is equal to the story link. So I'm just going to copy that and paste it in. Remember that in order to not clash with the reserved class keyword, we have to add a underscore afterwards. Now this should be our article tag. And if we go ahead and print it, then you can see that we get this exact anchor tag. But if we want to get hold of the text that's actually in the anchor tag, then we have to go one step further and call the getText method. That's also from Beautiful Soup. So now when I run that, you can see I only get the actual text of the article. Let's work on some of the other pieces. So this is the article text. And then if we want to get hold of the article link and the article upvote, see if you can figure out how to complete these two parts as well. So we want the HTML link that is, of course, all of this, HTTP, etc. And then we also want to get hold of the upvote, which is this little number right here. It's inside a span with a class of score. All right, so let's do the first thing, which is article link. Well, we can actually already tap into the same article tag we already got up here. And instead of saying get text, we can use the get method to get the specific value of a attribute. So what we want is, of course, the href. And then the article upvote, we'll have to tap into our soup and find the tag with a name that is span, because this is what we're looking for, and has a class of score. Like this. Finding this particular tag is not enough. This actually just gets us the tag. If we want to go further and we actually want to get the text that's inside that span, which is of course the 19 points, then we have to dig one step deeper and call the getText method like this. Now, if I go ahead and print out the article text and the article link, and also finally the article upvote, then you can see I get all three pieces of data that I'm interested in. Now, instead of getting the first occurrence, I want to get all of the ones that are on this page, so all 30 results. Now, in order to do that, I have to change the find to find all, both here and here. This way we get a list of all of the articles, and I'll get a list of all of the article upvotes. So now it's going to be a little bit different. In order to get all of the text and all of the link, then I have to use a for loop. So I'll say for article tag in articles. So articles is of course this list where we find all of the anchor tags with a class of story link. And then I'm going to loop through each one of those, and for each of the tags I'm going to get the text and also get the href. I'm going to create two new lists, article text and article links. And then I'm going to save each of the new articles into those lists. Like this. And in fact, we could probably simplify this a little bit by refactoring and renaming the article text, so the singular version, into just text, and the article link to just the link. So now let's print out the lists. So the article text, the article links, and the article upvotes. And this find all gives me a list, and I can't call get text on the list. So I'll also need to create a new list. So I'm going to choose to use list comprehension here. So I'm going to say for score in all of the scores, we're going to create a list using each of those scores, and we're going to call get text in order to get each of them. This is the same as writing out a for loop like this, but it's obviously much shorter. Now when I hit run, you can see that each of my lists are ordered. So this is the first article's text, this is the first article's link, and this is the first article's points. What we want to do is we want to get the article upvotes into a number format, so an integer. And to do that, we of course have to get rid of the points that comes afterwards. But notice how each of these items are strings. So that means we can split the string by the space and only get hold of the first item in that space. Let me show you what I mean. So we've got all of the article upvotes. Let's go ahead and just print out the first item. So now we just get the first item, which is 40 points. Now, if I take that item and I call the split method, then it's going to split every word in the sentence. By default, it splits by the space. Now, if I run this code, you can see I get a list where I've got the first item being 40 and the second being points. So it's basically split that string by the space. Now the next stage is I could get hold of just the first item that comes from that list, which is now 40. If I now finally wrap it around an int, then I can turn that into an actual number. Don't worry if your number changes, because you're pulling data live from a website. That upvote number can change in any second. So this is the method how we can get hold of the actual number from the upvotes. Now we're going to apply all of this dot split and also getting hold of the first item into our list comprehension. So for each of the scores that soup finds, we're going to get hold of the text and then split the text and then get the first item from the text. And then finally, we wrap all of this around an int and turn it into an integer. Then if I go ahead and uncomment all these lines of code, then you can see I've got all of these numbers being printed out, which means I can now sort them. I want to get the index of the list item that has the highest value. And then I want to use that index to pick out the title, text, and also the link from these two lists, because they're all ordered in exactly the same way. So this first item corresponds to this first link, corresponds to this first upvote. And I want to pose this to you as a challenge. Can you print out the title and link for the Hacker News story with the highest number of upvotes? Since we're working with 3 different lists at this point, you'll have to find the index of the largest number inside the article upvotes list to accomplish this. I'll give you a few seconds to pause the video before I show you the solution. All right, here's the solution. We can use the max function that Python comes with to get the largest number from our article upvotes. And then we can print this largest number and see if it works. So we've got 1,312. Now, once we've gotten hold of the largest number, then we can find its index from this list. So we can say article upvotes dot index, and then we find the index of this largest number. Now if we hit run, you can see that we're getting index number 27. So instead of just printing out that index, we can print instead the article texts with that index, so passing in the largest index, and also the article links and passing in the same index. So now if I hit run, you can see that the most popular article at the moment on this page has this title text and this particular link. Of course, for you it'll be different because it depends on what's currently showing up on Hacker News. But if I refresh this page, you can see that this article with 1,313 points is, of course, the most popular article, and it is the one that's about Mozilla. You can imagine a use case for this where every day we scrape all the data on Y Combinator and then we send ourselves through a text message or through an email the most upvoted title and article so that we can just look at that one thing. And you've seen now how we can use the request module to get hold of the text, the HTML code from a particular website, and then use Beautiful Soup to pass through that website and then to get hold of the specific parts that we want by using find all or find, and then getting hold of the text or getting hold of the link or getting hold of any other thing that we want. So now that we've seen how we can do web scraping using Beautiful Soup, in the next lesson, I want to talk a little bit about the ethics of scraping websites and when to do it and what you can use the data you get from this for. So for all of that and more, I'll see you on the next lesson. Now that we've learned how to do web scraping with requests and Beautiful Soup, it's time to step back for a moment and have a think about what we're allowed to do and what might not be a good idea when we're scraping data from other websites. Because after all, we don't own that data, right? When you think about services like Google or Bing or any other search engine, essentially what they're doing is they're constantly scraping data from all of the websites that are listed on the internet. And that's how they manage to get the information about what's on each page and for it to show up for users who use their search service. Now, we have to step back for a moment and think about what is the law on web scraping? What is legal and what is illegal? Even as we were looking at Hacker News just now, I noticed that one of the articles, in fact, talks about the Genius lawsuit with Google. And in terms of recent history, there's two really famous cases, which is Genius suing Google because they're saying that Google is scraping the song lyrics from their website and they're actually displaying it without taking people to Genius. So, for example, if we're looking at the lyrics for Code Monkey, you can see that Google automatically shows the lyrics straight inside of Google. That means that a user can potentially just get all the information they need, say all of the song lyrics to this song, without ever needing to visit the website where this lyric might come from. And that lyric might have been compiled by somebody on Genius. Genius is a lyric annotation website. And of course, as with all websites, they rely on users actually visiting their website to make money or to show ads. And if Google simply just shows it in their search result, then this can be a problem for websites like Genius. So they sued them over this and actually ended up losing the lawsuit. Another really famous example of a lawsuit over scraping is HiQ versus LinkedIn. So HiQ was scraping data from LinkedIn to use commercially. So LinkedIn sued them and ended up losing in the lawsuit. Based on these lawsuits, we have a little bit of a better idea of what is legal when it comes to web scraping and what is not legal. The law actually seems to favor web scraping in the sense that you're allowed to scrape a website's data as long as you think about a couple of things. A lot of people have been writing about web scraping being legal based on the LinkedIn versus HiQ case. But the important thing to remember is that this is not a blanket sort of you can do whatever you want scraping any website's data. It only means that data that is publicly available and not copyrighted is probably legal for companies to scrape. Now, if you're using this data privately, like we are creating some sort of service for ourselves, then it doesn't really matter. You're just a user. The difficulty comes when you're trying to commercialize that data, when you set up a business and your business kind of involves somebody else's data. That is a bit of a gray area. Now, the things that we definitely know are that you can't commercialize copyrighted content. So if you scrape data from YouTube and you scraped the video data, you can't just use that video on your own website. That's still not allowed because that video is copyrighted and it's created by a YouTube user and the copyright belongs to that user, not to you. So this is still illegal. This might also apply to other things like a Medium blog post that somebody else wrote or a piece of music that's being hosted on Spotify. So copyrighted content you can't commercialize. The second thing is that you can't scrape data that's behind authentication. So if you have to log into Facebook in order to scrape the data, then that's pretty much illegal. And the reason for this is when you sign up as a user to any of these services like Facebook or Twitter or Instagram, there's a policy in there that you're agreeing to when you sign up that says, I agree to not use this data that I obtain on this website commercially. But the data that is not behind authentication, so any website that you can access as it is, they can't bind you to a policy because you haven't agreed to anything. So if a website has data that's just out there in the open that you can access without logging in, and the content is not something that can be copyrighted, then it is fair game legally. Now, just because it's legal doesn't mean that you can actually do it. A lot of websites will use CAPTCHA or reCAPTCHA in order to prevent bots like our Python code to get data from their websites. Every single time you're agreeing to one of these CAPTCHAs, it's testing whether to see if you're actually a real human or if you're just a bit of code that's trying to access their data. CAPTCHA was the old version where you had to type in some squiggle letters, and reCAPTCHA is the new version where you just have to tick a checkbox. And it's actually really interesting how it works. It looks at things like how your mouse approaches the checkbox, how you maybe quiver a little bit before you actually check it, and other things like your cookies and the stored data that they have on you. Essentially, this service is used by websites to prevent people to scrape their data using a bot. The other thing to remember is that, if you get sued by somebody like LinkedIn because you're using their data and you're building a business on it, like HiQ is, then you can at any moment be hit with a really expensive lawsuit, and you're going to have to pay a lot of money to lawyer up in order to contest this and actually to fight them in court. Unless you have the money to lawyer up and fight a company like LinkedIn, it's really important to know what are the implications of web scraping, especially when you're selling that data as a part of your business. But in addition to the sort of legal side of things, the other part that you should really think about is the ethics of web scraping. This is basically putting aside what is legal and what is illegal, but more thinking about what is right and what's wrong. Because let's say that you've built a website and you've got some sort of bot that's constantly scraping it for data that, has been generated by your own users that's really precious and that you might even charge for. Then is it really right for somebody to do that? So I often follow the rule where if I don't want something to happen to me, I try to not do that to others. In terms of the ethics, a couple of things that I would recommend abiding by is if you come across a website and they have a public API, which we've already learned about and we know how to use, then always go for the API. If it requires an application, then apply for it. Don't just go ahead and try to take their data when there's already a route for you to use and access their data. The second thing is to respect the web owner because, you don't want somebody to access your website 1,000,000 times a second, potentially making your website go down, or it could count as a DDoS attack where it affects other users using the website. When you're on a website, they actually provide a way for you to tell what it is that you can scrape and what it is you can't. at the very end of the URL, so after the .com or .co.uk, if you put a / and put robots.txt, you can see this is the advice that they give to any bots that are potentially scraping their website. User agent is the person who is scraping, the person or the bot that's scraping, and it tells you what are the things that it disallows. So it doesn't want you to access the / vote, / reply, / submitted, / thread. So basically any of these endpoints are ones that they don't really want you to use. For example, here I've accessed the / reply, which is a way to log in and reply to a particular comment. Now, that really shouldn't be a bot kind of action, because then it means the data that's generated, all the replies on here, will be automated, right? You actually want humans to comment and reply on the articles rather than some sort of robot. So these are the paths that they don't want you to access as a bot. And finally, it even tells you a crawl delay. So this is the number of seconds that you should leave between each time you hit up the website. If we're writing Python code and we're using Beautiful Soup and Response to scrape data from Y Combinator, we could potentially get that code to run every fraction of a second, right? I could just write a for loop and just get this to keep scraping again and again and again. But that means that you're adding a lot of extra traffic and a lot of extra demand on their servers, which could potentially mean that real users, real humans who want to access their website might not be able to do it at a fast speed. So this is the reason why when a lot of people are accessing the same website, say when a new ticket has been released for Glastonbury or some sort of big concert, that the website can go down, it's because a lot of servers can't cope with so much demand. And when that demand is coming from a for loop, then you can imagine that you're just adding a lot of extra work onto the web server. So always respect their crawl delay if you see one in the robots.txt. And even if you don't see one, just try to limit your rate so that you don't max out their server. I recommend not scraping more than once a minute. The Y Combinator robots.txt is actually quite permissive. It allows you to do pretty much anything you want, but that's not true for all websites. If you look at the robots.txt for LinkedIn, you can see that they really don't want anyone to scrape it. There's a bit of legal jargon here. There's a lot more disallows that you can see, right? This is probably not a website where I would scrape their data and try to build a company around. So remember that this is a piece of text that the website owners have written for you to look at to see what you can do and you can't do with their website. So before you scrape a website, always go to the root of their URL and check out their robots.txt. And follow the ethical codes of conduct when you're trying to commercialize a project. So this is just a quick tip on the law and ethics of web scraping, just so that you don't get into trouble in the future. Now, here's a question. Have you ever gotten into a situation where it's evening time and you want to watch a movie, but you don't know what to watch? Like, there's just no ideas coming to your mind, and everybody's sitting around the TV like, well, what do we do? So what if we scraped a list of the top 100 movies of all time, and you pick one from there? So I recently came across this article on Empire, where they list the 100 greatest movies of all time. And you can see that it goes from 100 all the way down to 1. These are supposed to be the top rated movies that have ever been produced. And I always wanted to watch through all 100 of them and check off each one as I go along. So this is what we're going to be doing for our final project today. You're going to be scraping from this website the 100 movies, and you're going to be using Python code to create a text file called movies.txt that lists them in order, starting from 1. Notice how each of these are just the titles of each of these movies. Essentially, it's this part that you want. And because the listing starts from 100, you'll have to figure out how to flip it the other way so that you get it starting from 1. But essentially, this is the goal, and this is the project for today. You're going to have to use what you learned about web scraping, but also other things that you've learned along the way about Python. Pause the video now and try to complete this challenge. So here I've created a brand new blank project, which I've called Top 100 Movies, but of course that doesn't matter. But in the main.py is where we're going to be doing all the serious stuff. So the first thing we'll need is to copy the URL. And at the time when you're doing this project, this URL might change. So don't get it from here. Instead, go to the course resources and copy the URL from there. Once you've got the URL, we're going to paste it into our main.py and save it as a constant. In addition, we're going to have to import all the things that we need, including requests and also the BS4 module, where we can get hold of our beautiful soup. I'm going to need to install both of these because I don't have them yet. So I'm going to click on the red squiggly line, install requests, and also install beautiful soup. Once that's all done, then my red squiggly lines should be gone, and I can now start using my request module to make a GET request to this particular URL. And I'll save the response that I get back as the response. The actual HTML file, so the website HTML, is actually under response.txt. So this is going to be the raw HTML text, and this is what I'm going to be using to use beautiful soup to parse. So now we make soup, and we're going to use beautiful soup, and we're going to pass in our website HTML and also the HTML.parser, which is the method which we're going to use to pass through this website. Now that we've made soup, let's go ahead and print out our soup in a prettified format so that we can just see what it looks like. So let's run our main.py, and we can see that we've got basically that entire website's HTML being printed out here. Now comes the part where we need to use our Google Chrome Inspector. So the part that we want from this website is just these lines. Now, of course, if we didn't know how to code, we would be here copying and pasting for hours on end, and we would die of boredom, or we'd get repetitive strain injury from doing so much copy and pasting. But because we know code, we know better than that. So let's get hold of the part that we want. Let's right click and click inspect. Now we can see that this lives inside an H3 with the class of title. Now let's just check against one of the other pieces that we want and just make sure that they've got the same structure. So this is also inside an H3 with the class of title. So basically, as long as we can scrape this entire page and get all of the H3s with the class of title and get the text that's contained inside the H3 element, then we're golden. Let's go ahead and do that. So instead of printing our soup.prettify, I'm going to tap into soup and I'm going to say find all. The thing that I want to find has the tag name of an H3 and it has the class of title. So that all came from our inspections right here. This should get us a list of all of the H3 elements with this class, and we should be able to save that into a variable called all movies. Let's print all movies and see what we get. Now we've got a list of all of our H3s, and we're now going to go one step further and fetch the text from within these H3 elements. We do that using the getText method, but we can't do that on the list, so we're going to use list comprehension. So we're going to say the movie titles is equal to a new list, and in this list each item is going to be formed from a movie in the all movies list. And this new item is going to be created by taking each of the movies in the list and then calling getText on it. Now, if I go ahead and print my movie titles instead of all movies, then this is what we get. We get all of the titles of all 100 movies. Now we want to reverse this list so that we can put it into a text file starting from 1 going down to 100. So there's a couple of ways that we could do this. One is we can use the Python splice operator. So we add a set of square brackets and then we add a colon, colon minus 1. And this will reverse the order. And as always, you can find out this information either by Googling or through what you've learned before in previous lessons. So this is the syntax that we're using, which comes from the slice operator, where we have a start, a stop, and a step. So in this case, the start is at the very beginning of the list, the stop is at the very end of the list, so we don't have to specify those because they're the defaults. And then the step is basically -1. And this syntax will reverse that list. Now, alternatively, you can of course also use a for loop where you create some sort of n in a range, and the range again can take a start, stop, and step. So you could start at the end, so the length of our movie titles -1, because remember, lists in Python start numbering from 0. So the very last item is actually at the total number -1. And next is going to be the end, which is going to be 0. And finally, it's going to be the step, which is -1 each time. So this time we start off from the very end of the list, go back to the beginning, stepping by -1 each time. And this way, if we print n, you can see that this is going to give us basically all the way from 99 down to 1. And we can use that to tap into our movie titles and get hold of each of the items at index n. And because range actually doesn't go beyond the end, we actually have to put -1 there if we want to get the very final one, which is number 100. And you'll notice also that there's a bit of a typo here for number 93. And this is actually not our fault at all. It's in fact in the original Empire post, they actually screwed up, and this should be number 93. Because we're scraping data, we can't really be picky. We're just going to end up with what we end up with. So I'm going to choose the method where we actually take the movie title and then we use the splice to get hold of it in reverse. And I'll call that the movies. And now we can create our new text file. So with open, we're going to create a new file called movies.txt. And we of course have to change the mode to write mode so that we can actually create this file. And then because this file movies.txt doesn't exist, once this line runs, it's going to create that file and then we're going to write to it. So we're going to say file.write and we're going to write each of the lines in our list of movies. We can again use a for loop. So for movie in movies, let's go ahead and write the name of the movie. And then let's add a new line operator, so \n, so that we get each of the movies onto its own line. Now, finally, if I run this code, then it's going to create our movies.txt. And if I take a look at it, you can see it's now got all of the 100 movies listed on here from 1 down to 100. And now you can go through this list and delete the ones that you've already watched and then continue watching through the rest of the list. I hope you had fun trying out web scraping by yourself in this project. So that's all for today. Take a look at what you've done. If there's anything confusing about the class or ID or HTML, then be sure to review some of the lessons in the previous 4 days. That's all for today.